Good afternoon, dear members, industry colleagues, and respected speakers.
Jamli, wait, hold on.
No, Jamli, we'll do the film first. No? We'll run the video.
Oh, sorry. Okay. Good afternoon, dear members, industry colleagues, and respected speakers. A hearty welcome to all VDMA Web Seminar for Robotic Automation Trends in Manufacturing, organized by the German Engineering Federation, VDMA, in association with Automatica. We hope all of you and your family and colleagues are safe and doing well. I am Jamli, based out of the Mumbai office of VDMA, and I'll be taking you through the session. I'll request all the speakers to kindly keep themselves off mute to avoid any disturbance. Before we continue, I'd like to remind all of you that you can continue to post your questions during the Q&A section, and this will be answered in the last leg of the web seminar. Next slide. VDMA is and will always be committed to India. VDMA, the Mechanical Engineering Industry Association, was founded in November 1892 and is the most important voice for the mechanical engineering industry. VDMA represents around 3,300, mostly medium-sized companies, making it the largest industry association in Europe. Currently, the members contributing 78% as exports, which is equivalent to 232 billion euro production. Recognizing the very early significance of India as a future market for the member companies, India was one of the first overseas offices among the BRIC countries. VDMA is the only German industrial association having well-established offices in India since several years, with the offices located in Noida, Kolkata, Mumbai, and Bangalore. Next slide. The VDMA Robotics and Automation Association had organized the first Robotomation Symposium, the Robotic Automation Trends in the automation industry in June 2019 in Pune. More than 235 participants had attended the prestigious event. The symposium focused on the global robotics and automation trends available to the Indian automotive industry. The speakers at the forum were both from India and Germany. We were also honored to have the Counsel General of Federal Republic of Germany, Dr. Jürgen Mohart, and Dr. Rabeh Firodia, the chairman of to join us as a chief guest. During this event, very well-known members of VDMA, namely Baumer, Festo, Kuka, Schunk, Siemens, and Zimmer GmbH, conducted application-oriented presentations. We would once again host the Robotomation Symposium in 2021, and this time in Gurgaon on the 19th of February. The focus of the symposium would have a broader reach to the applications in the manufacturing industry. The details of the symposium will be shared with you shortly. For today's web seminar, we shall begin with a short address from Mr. Rajesh Nath, Managing Director of VDMA India, and this will be followed by the special address of Dr. Mohart on the importance of the strong Indo-German collaboration. We'll also begin then with the technical presentations, starting with Baumer India on vision-guided robotics, enabling robots to see, Zimmer Group on the smart end of arm tooling solutions, Festo India on the latest trends in automation and collaboration with robots, and Kuka India on the latest technologies and robotic applications in the automotive tier 1 and industry. The Q&A, as I mentioned, will be after the presentation. Next slide. Mr. Nath has been a synonym and a face of VDMA for almost 20 years now. He has more than 3 decades of experience working in various industries, both in Germany and India. He's also been accorded the Cross of the Order of Merit, which is the highest civilian order from the German president promoting Indo-German trade. With no further delay, I'd like to hand it over to you, Mr. Nath.
Yeah, thank you. Thank you, Jamli. And good afternoon, members and friends from the industry. Hearty welcome to the web seminar on Robotic Automation Trends in Manufacturing, being organized by the German Engineering Federation, along with our competent partners, Baumer, Festo, Kuka, Zimmer, and this event is powered by Automatica of Messe Munich. We extend a warm welcome to our chief guest today, Dr. Jürgen Mohart, Consul General, Consulate General of the Federal Republic of Germany in Mumbai, and all our distinguished speakers from the VDMA member companies. Friends, COVID-19 has not only proved a threat to life and has caused unprecedented shock to the global economy. The pandemic hit the manufacturers in an unprecedented and unexpected way. For the first time in modern manufacturing history, demand, supply, and workforce have been affected globally. The spread of virus impacted production in several countries, resulting in huge losses to the economy. The virus, in fact, highlighted various critical gaps in the manufacturing sector. Companies need to build their business continuity plans afresh, need to review the existing manufacturing supply chain models, and explore automation possibilities to reduce the impact on production lines in the future. While in the pre-crisis era, automation was viewed as a means to innovate, reduce cost, and gain a competitive edge, now the purpose has shifted to survival and damage limitation. To mitigate global supply chain risks of future crises, manufacturers will consider bolstering their in-house capabilities and perhaps limiting the outsourcing to other countries. The pandemic will intensify the need to automate. In fact, the focal point in this drive to automate would be especially in jobs that have the 5D factor, are dull and repetitive, difficult and complex, dangerous and hazardous, dirty and polluting, and now the new dimension of distancing and safety. Although the degree of adoption may vary depending on the industry and the readiness of the companies to make huge investments at this time, the COVID-19 crisis has certainly acted as a catalyst in transition to automation, especially in building resilience among businesses for future disruptions. Friends, the need of the hour is to adopt baby steps in automation, which can generate a faster return on investment and can be implemented without high capital expenditure. Artificial intelligence, machine learning, and robotics would drive businesses to help manufacturers to produce quality products at a better cost, and through that to give them the competitive edge to progress and prosper in these times. The important role of automation in manufacturing is here to stay, and the journey to enhance automation and robotics in the reboot phase is just beginning. As India strives to become a preferred manufacturing hub and be globally competitive, it is critical for the industries to be digitally transformed and be future ready to manage the fast changing businesses and technology landscape. The industrial automation industry in India is predicted to grow at a CAGR of 10 to 12% up to 2022 and is expected to touch $3.5 billion by 2022. It is essential to achieve the ambitious target of making India a global hub for manufacturing, design and innovation, and augmenting the share of manufacturing in the GDP of the country. India needs to leapfrog ahead to achieve the employment and productivity growth needed. Fortunately, it has many opportunities to do so. Global trends such as digitization and automation, shifting supply chains, urbanization, rising incomes, and demographic shifts, and a greater focus on sustainability, health and safety are accelerating or assuming a new significance in wake of the pandemic. For India, these trends could manifest as growth boosters that become the hallmark of post-pandemic economy. As per a recent McKinsey report from August 2020, these growth boosters could create about $2.5 trillion of economic value in 2030 and support 112 million jobs, or about 30% of the non-farm workforce in 2030. Friends, automation offers accuracy, consistency, scalability, and traceability. Hence, we look forward to informative and insightful presentations from our speakers today to share their experience and application of automation and robotics in the manufacturing industry. However, before that, I would like to invite our chief guest today, Dr. Yogan Mohad, to address an important topic, importance of a strong Indo-German collaboration. Friends, allow me to briefly introduce Dr. Mohad. Dr. Mohad is the Consul General of the Federal Republic of Germany in Mumbai. Before coming to India, he was in the German embassy in Colombo as ambassador to Sri Lanka and Maldives. He has done his Masters of Business Administration from University of Cologne and Sofia University, Tokyo. And he was also a PhD in International Relations as Japan Foundation Research Fellow at Sofia University. So, pleasure to have you with us, Dr. Mohad, and we look forward to your address now.
Mr. Nath, dear friends of VDMA, just give me a sign. You can hear me all?
Yes.
Good? Okay, thank you.
Yeah.
It's a pleasure, of course, to be back here again. And I am the least one who is an expert on robots, but I can share you my favorite activity where I use robotics is my vacuum cleaner back home in Germany. Since I have it, I can clean every day, and I don't have to run this stupid household course, have my wife in my neck until I should participate full time in sharing housework. And this was one of the best investments. And I'm very happy to see that automation, and of course, this also has for the end consumer a lot of benefits to come around the corner. I'm very happy, I said, of course, to be again here with VDMA. I don't know how many events we have done together this year, because it's in those times where you don't meet at fairs like Automatica, right? It's more important that the Bridget VDMA uses the platform, the webinar platform, virtual platform, to bring people and experts together on different topics and to share. And it can be only a weak substitute for an event where Automatica, where you really can also see machinery, can talk to the engineers and all things like that. But I'm confident that all those things are coming back again. And so far, I think VDMA is here to all of you and one of our major partners, also for the future, to assist you, the newcomers, as all you are the well-established ones in India, to bring us together and share the experience for the further development of the Indian economy and also on your own business. Mr. Nath has said this. We have seen this year complete shock. A shock for industries, of course, and economies. A shock also for my consulate, because I've never thought that I would be for a couple of months nothing else than a travel agent trying to help Germans stranded here back home. All our jobs have basically completely changing. And even now, today's is, I think all of you are responsible for running companies. The number one concern is every morning is just how to evaluate the COVID situation, how to make sure that, first of all, the health is assured of all our staff and all working for us, because otherwise our operations will not work. It's a completely think on how we're running our daily businesses and what became our main missions. But coming back to this shock, Mr. Nath mentioned it. I think I see a triple shock. It's not only, as Mr. Nath has mentioned, a supply side shock and, of course, a demand shock for you as a company. There was also a policy shock. What do I mean with policy shock? The policy shock was that many of the companies were interpreting or misinterpreting the crisis in different ways, which are not really favorable for global businesses, right? We're seeing tendencies of nationalistic stricter trade policies, trade barriers coming up, what we call as decoupling, for example. That is not, the companies not only see the market forces, but they also have to adopt to new, unforeseen and unpredictable government policies, all of a sudden shooting up all around the world and having huge impact on all industries. Then, of course, there's another shock, and we have seen that when the world came to a standstill, it was a moment for rethinking. And the industries of the future, not only your clients, but also yourself, means there will be a change, and we'll have a decade coming in sooner as we thought for more sustainable and carbon-free economy. And you see that how it changed the thinking in the companies, in societies, also related to the COVID situation, that sustainability and achieving carbon-free economies, carbon-free businesses, carbon-free or carbon-reduced products is coming much faster speed than we ever believed before. Today we are here also with the support of Automatica, and of course Automatica has been cancelled again. And I'm a huge fan of trade shows, and I think they will never be replaced, because you have to bring people together, and even if you are not there in person, and you don't want to buy, it's still like a shopping. And I still remember more than 20 years ago, around 2000, when everybody thought the world would just be reduced as a business relations on B2B platforms already in the internet. It just did not happen. And that's, I'm still believe that there will never be the end of the classic trade show. And also when we talk about Automatica and digitalization, even those things who are driving digitalization and automation, something virtual, there will be still a need for people coming together to see and talk to each other and make first contacts. So Mr. Nath mentioned it. We have seen, also the investments, the COVID situation, and the situation, supply chains which have been interrupted, where many companies need to adopt to a new model. It means not only bringing things home, it could mean by industries to have more countries where they have to invest, and not only relying on one region or one country. But I think this brings huge opportunities now for new businesses, because also here I see in India by German companies, there's not really somebody who's scaling down. No, they rather see how can we make our business more resilient for the future. And of course, the number one topic is also for the local companies is automation. This has many drivers, of course. It could be labor laws, it could be availability of labor. A huge issue, of course, was here in India, that labor returning home in the villages, not coming back. This is many companies who needed workers were facing this problem. There are many factors, and of course there was a huge boost in digitalization. I think we all gained much more confidence on what can be done online, what can be done from somewhere far away, and which will heighten the confidence also of decision makers in the boardrooms, rather to invest and look into more complicated automated systems. Industry 4.0 just wanted, and even if they themselves might not understand what it really means. But I think the threshold has come down, and the very basic example, of course, has been those companies we have highly automated, that for them it was easy to have social distancing. For them it was easy to follow all the SOPs in the factories, right? Because a robot is just immune to a virus. It's very easy. A machine is immune to a virus. Though I think there will be a lot of thinking also from this side in not only how to reduce costs, how to increase my productivity, how to be more flexible in production, but all these very more human aspects have shown us a completely different benefit from the side. And then you have seen, it's what the boost of digitalization is, not like us sitting in home offices and doing things from home, but it also gave us a lesson what the things what we can do from home can be done over the internet. And I myself have always been impressed when I'm sometimes coming company, and all the service for the machine is done somewhere from Singapore or even Denmark. And what is possible today already with these new modern technologies, and how Industry 4.0 and artificial intelligence help us machines to control machines and to do the servicing on the right time and foresee problems. And I think this is a new era beginning. So as I said, coming back, so this new drive, first of all, to look in more diversifying supply chains, which means investment, but of course to reorient our industries in sustainability and more carbon neutrality globally. It's not just something what the European have in mind, that this is going to fuel a new demand into robotics and automation, and for further investments worldwide in the post-corona area. And of course, it's now the time also for us here, because you are bringing as VDMA members, you have the expertise, you have the knowledge. It's time here for us also to reach out to all your clients here and help the Indian partners also to modernize their industries, because there is no other way to face the global challenges and the global markets there outside if you are not competitive. And there, I think the German industries with the products they offer, with robotic automation trends, what hopefully you are discussing today, will be the most suitable partner for Indian industries to upgrade their capability to be competitive in worldwide markets. So thank you very much for having me here. I wish you fruitful exchanges. And because I don't have the floor anymore, I wish you here, of course, Merry Christmas. All the best for the new year. And I hope that we all come back to the old normal as soon as possible, with even much better market opportunities for you all. All the best, stay healthy, stay safe.
Thank you, Dr. Mohad. Thank you so much for your kind address. And I think you highlighted some of the important points that would also be discussed during this web seminar, especially topics on Industry 4.0, artificial intelligence, digitization. And also on behalf of VDMA and all its members, I would like to thank you, Dr. Mohad, for the immense support and the active you have played in, even during the pandemic, in keeping the German industry connected in your region and being active in so many events, interacting with the government. I think you have been really a pivotal support for the German industry in Western region, Dr. Mohad, and sincere thanks to you and your team on behalf of VDMA and all our members. We also wish you Merry Christmas and hoping that 2021 will help to bring back the old normal, and wishing you also a healthy, happy 2021. Thank you so much, Dr. Mohad. Yeah. I would
Thank you so much,
like
Jim.
to Jamie to take it forward.
Yeah. Thank you, Dr. Mohad and Mr. Nath. I'm pleased to welcome our first speaker for today, Mr. Vikas Danveka, who's the Product Marketing Manager at Vision Technology for Baumer India, for his presentation on Vision-Guided Robotics, Enabling Robots to See. Mr. Danveka has 20 plus years of experience in the industrial automation field. He has worked in different domains, which include PLC and CNC automation, robotics, and vision systems. He's also having a wide experience in automation domains for industries like automotive, textile, steel, FMB, pharma, FMCG, etc. He's an active member of ISA Pune division, where he's holding the position of a president, and he's also a committee member in the Advanced Control and Robotics division. Over to you, Vikas, with no further delay. Thank you.
Thank you, Jamli, for the introduction, and a very good afternoon to all of you, all the panelists, Mr. Nath, Dr. Mohad, and all the audience out there. I would like to thank VDMA for giving me this opportunity to speak on this very interesting topic of vision-guided robotics. The robotics is not new for us, like what Mr. Dr. Mohad said, that now robots have invaded our households, and we soon will see that there are robots all around our houses, cleaning floors and doing a lot of household chores. But the topic for today, we are focusing more on the automation in the manufacturing industry. So I'm going to talk about how the robots are enabled with eyes, for example, like how cameras can help the overall build the overall efficiency of the robotic process. So we all know that robots have been around the manufacturing industry for decades now, and also the machine vision per se is also not new to the industry. And both these technologies have grown quite well. They've matured quite well in their respective domains. But of late, both these technologies have converged and complemented each other to make the whole process much more efficient and reliable. So I'm going to take you through some of the insights about vision-guided robotics, some of the applications, some of the challenges which are associated, some technological challenges which are associated with vision-guided robotics, and we'll also see what are the solutions available to address those issues. Next slide, please. Yeah, so next one, please. Yeah, so typically all the robots, we all know that they need to be programmed. They need to be programmed for a particular process. For example, be it a welding process or a gluing process or a pick and place process, right? So the robot has to approach that particular position from where it has to start its operation. So now, normally these positions are programmed using teach pendants, and then there are several steps associated with the overall process. So these need to be programmed for the tasks that they perform. And the objects on which the robot has to perform any operation, these objects have some defined coordinates, and these coordinates need to be conveyed to the robot. Accordingly, then the robot comes to know that from which position it has to go and it has to start its operation. So typically all these objects would always have a fixed position, and the robot knows exactly from which point it has to start its operation until what point it has to reach. So it is kind of assumed that every object would come in its fixed position, and even if there are any variations in it, that would be taken care of through the robotic programming. Next slide, please. So there could be several situations where the object might not come at the same position always. There could be some variations. These variations could be because of some of the machining tolerances of the object, or because of the fixturing tolerances on which the object is mounted, or there could be situations where the objects are placed randomly and the robot has to perform operations on those objects, or either the robot has to do pick and place of the randomly placed objects. So in those cases, it becomes imperative for the whole system to know where exactly the object lies, where exactly is the start point of that start point of the process for that object, right? So in those cases, machine vision can help robots to find out the real-time position of these objects. And in such cases, the camera systems can definitely help to identify some of the shifts of the objects in the fixtures. So these offsets can be conveyed to the robots via the vision systems. Okay. Apart from that, vision systems can also help identify if there are any how much is the free space available for the gripper to do that pick and place or any operation. Then whether there is any overlap between two objects, whether the object is okay to be picked up, and how much is the space, is there any obstruction around for the robot to process. Apart from that also, yeah, next slide please. Yes, so typically the applications for vision guided robotics, there are four major types of applications that we can say. The slide what you can see over here has the objects or the products which are placed randomly on a conveyor. So end users are more frequently requesting for applications like random bin picking. So there are objects which are placed in a bin randomly, and the robot is expected to pick up the objects from those bins. Now here the objects could be overlapped on each other. So the vision system should be intelligent enough that it has to pick up the most easiest object from the bin and place it on a conveyor or whatever. So the new with the advent of latest technologies like artificial intelligence, and it has rather improvised the whole application of random bin picking. Likewise, there could be objects which are coming along a conveyor, but still they are placed randomly on the conveyor. So there also vision systems can be integrated with the robots, and it can very well help the whole process to be executed much more efficiently. Next slide, please. Then there could be cases where the fixturing of the objects might have some tolerances, and in those cases the VGR or the vision guided technology needs to be able to pick and place objects with variations in part orientation in location to reduce the costs associated with fixtures. So making those complex fixtures is also expensive. So vision guided robotics or VGR can help reduce those complexity in fixture designing. Next slide, please. Then it also provides higher flexibility. For example, if there is an application for object sorting, there are several objects which are mixed up, and the robot needs to sort the correct object and place it on a different conveyors, on a production line or an assembly line. So there also vision guided robotics plays a very important role to identify the products which are coming along the conveyor. Lately, there has been very much advancement in the technology, or new applications are coming up, such as waste management or segregation of wastes, plastic wastes to be segregated separately, glass waste to be segregated separately. So this application is again being automized in large ways, and vision guided robotics is helping this application to be made possible. Next slide, please. Apart from this, the end users are also requiring an increasing convergence of robots and vision technology, wherein the robots and the cameras are used to inspect the overall quality of an object. So the cameras are mounted on the robots, and these robots move around the entire component, and they do all the physical visual inspection checks, quality checks for that component. So this is what we call it as the guided robotic inspection, is also gaining a lot of popularity nowadays. Next slide, please. Yeah, this is basically the description of all the 4 applications that we discussed. So we can go to the next slide. Yeah, so there are certain challenges which are also associated with vision guided robotics, which are technological challenges, real life challenges when you integrate a camera with a robot. The first one being distortion. So the distortion can occur because of 2 reasons. The first reason is because of the optics that are used in the cameras, or the lenses which are used in the cameras. So always the image that we get from the cameras has got distortions along the corners. So it looks kind of a bulged image. So that needs to be corrected, because if the waypoint or the object lies in that distortion region, then we might not get the correct coordinates for the robot. Second reason is because the camera cannot be mounted exactly perpendicular to the object, because it might be the hindrance to the robot. So that also is one of the distortions that need to be compensated. Second important thing that has to be kept in mind, that the cameras understand the number of pixels. They understand the language of pixels, and these pixels need to be converted into coordinates for the robot to understand, because robots work in 3-dimensional space, right? So that's why even the pixel to millimeter or pixel to inches calibration is important. Third thing what is important is the Z calibration, because again the robots work in 3D space, whereas the object is placed on a 2D plane, or the vision sensors work on a 2D plane. So the cameras also need to know along the Z axis where the object is mounted, and those corrections have to be considered while any pick and place or any robotic application has to be executed. And last but not the least, coordinate alignment is very important, because the coordinate system of the vision sensor or the camera and the coordinate system of the robot, these two have to be aligned, so that the coordinates that are given by the vision sensor to the robot should understand or should be able to compensate and realign according to the feedback given by the vision sensor. Next slide, please. So as I said earlier, the camera often needs to be mounted at an angle with respect to the robot. If it is a fixed mount camera, and you can see over here that there's a table on which probably the object is mounted, and the robot has to perform its operation all along that object. So if a camera is mounted very near to the object, or exactly perpendicular to the object, it will obviously cause the hindrance for the robot to move around, and it might also cause accidents. So the camera is essentially required to be mounted at an angle and at a distance away from the robot. So it is always at an perspective, the position of the camera. Next slide, please. So that's why the calibration of camera with respect to the object is necessary, and that is done using such calibration target plates, which are basically the checkered plates, which are placed in place of the object, and the camera has to acquire the image. Now, once this to carry out this kind of calibration, obviously, since the camera is mounted at an angle, the image that we will get will be distorted. The same which we how the image will look like, we can see it in the next slide. So to the left, you can see that the image which we acquire, the checkered plate image that the camera acquired, is kind of distorted. So if we get such kind of an image, or the robot gets such kind of an image, obviously the coordinates that it is going to get calibrated to are going to be different, and it might cause wrong pick and places, or it might start the process from a different position than what is expected. So the camera is expected to do this compensation or this calibration. So after the calibration is done, the camera does the calibration, the image will look like what you see on the right side. So the right side, what you'll see is the calibrated image. So once this calibration is done, then you can be pretty sure that the camera knows how many pixels, or rather the camera knows how many pixels correspond to what millimeter, and that those values can be transferred to the robot for pick and place. Next slide, please. So to summarize about the distortion correction, the distortion correction should work real time. So the cameras or the vision systems which are deployed for robotic applications, they have to work real time. Second is that teaching and calibration of target is very, very important. So the cameras or the vision systems should be capable enough to do these calibration using the calibration targets. And it should be easy to set the measurement units, that is the world coordinates, the coordinate system between the vision system and the robotic systems. Now, to give a bird's eye perspective, the distortion correction has to be a real-time thing for accurate dimensional measurements. Next slide, please. So it is very important that the camera construction also has to be very, very robust. They have to be high in resolution, so that they are able to inspect the minutest detail, as well as able to do all the positional pick and place precisely. Apart from that, there has to be the protection for lens and the camera. They also need to be low in weight, because while calculating the payload capacities, if the camera is going to add on a lot of weight to the robot, then the whole application might go for a toss, or maybe the next level of robot has to be selected, which might make the whole solution very expensive. And also they have to be a proper ingress protection of IP65 or 67 has to be ensured. Apart from that, they also need to be resistant to high shocks and vibrations. Next slide, please. So what Baumer has for the vision guided robotics, Baumer has got two primary product lines for cameras, two types of cameras. The first are the vision sensors called the VeriSense, and they are complying with all the modern day communication technologies, which are easy for integration with the robots. Next slide. Also Baumer has come up with a dedicated product line for universal robots, that is XF or the XC900 series, which is UR plus certified and has got that UR cap, so that the integration with universal robot becomes very, very easy, and by following only a few steps, the calibration can be done very easily and very consistently and reliably, and the integration with universal robot happens seamlessly. Can we go to the next slide, please? Yeah, here's a short video of how easy integration of universal robot and the VeriSense can happen. Can we play the video, please?
Thanks to VeriSense vision sensors, vision-guided robotics for reliable and quick pick-and-place of unsorted objects has become easier than ever before. We show you how, making all manual hand-eye calibration superfluous. The robot in our example carries VeriSense and is already in position for image acquisition. Vision sensor, PC, and robot are interconnected. VeriSense is configured via Application Suite. VeriSense corrects image distortion in real time. For doing so, the vision sensor focuses on the intelligent calibration target Smart Grid. Just one click will teach and activate distortion correction, which allows for precise tracking of object positions. Unlike two-dimensional vision sensors, robots operate three-dimensional. VeriSense is capable of scaling the X and Y coordinates to align with the selected Z coordinate. A simple 3D rotation of Smart Grid is sufficient for teaching VeriSense its 3D position, which is basic for coordinate transformation. When completing the setup, the VeriSense communication is adapted to match that of the universal robot. Next is setup of the image processing job to enable object tracking in the vision sensor for coordinate transfer to the universal robot. Only a few minutes, and VeriSense has given vision capabilities to the robot. This opens up almost unlimited opportunities, including integrated quality control and part identification. Vision-guided robotics, thanks to Baumer, easier than ever before.
Yeah, can we have that presentation again, please? Yeah, thank you. Yeah, so apart from the vision sensor, the VeriSense, Baumer also has digital machine vision cameras which acquire the images and send those images to the PC for processing. Now these are IP67 grade cameras, that is CX.I cameras we call it. We have a very wide temperature range from -40 to +70 degrees, and these cameras are capable of powering up the external illumination by themselves. So you don't need to have an lighting controller for the same. And with the robust connectivity using M12 connectors, it ensures that the long-term stability of the camera is in place. So that's all from my side. Once again, thank you all for your attention, and we look forward to your business. Thank you.
Thank you, Vikas, for the very interesting insights on the vision industry. I'd like to now welcome our next speaker for today, Mr. Sunil Raibagi. Mr. Sunil Raibagi will be presenting on the smart end of arm tooling solutions. He has graduated in electronics and has a rich experience, close to 30 years in the field of automation and robotics. He is working presently as Vice President Strategy and Business Development for the Zimmer Group. And from Jan 21, he will take additional responsibility as Managing Director Asia. Many congratulations, Mr. Raibagi, on your new role. Zimmer Group Germany is well known for providing grippers, end-of-arm toolings, clamping, damping, and machine tool components, and has worldwide operations. Over to you, Mr. Raibagi, for your presentation.
Thank you. Today we will see about the smart end-of-arm tooling solutions. Next slide, please. As you see that we started early supplying the gripping or gripping solutions to the preliminary in the German industry, then we became worldwide. And around 2010, 2011, the industry 4 or connectivity came into the reality, and this mechanical grippers or mechanical and pneumatic operated grippers has become more end-of-arm tooling connected to the machines, and slowly this machine connected things has become IoT ready. Means you can see the simulations, digital twins, and many other areas, and these are nothing but function packages. Earlier the robots mainly were very specialized, but nowadays the robots has become commodity. You will see many robots in the market with the different functionalities, different things, and the end-of-arm tooling has become a specialty to do the processes. So on the end-of-arm tooling, you know, you are not only required to do the only pick and place jobs, but to do many jobs now. Drill, see, as Mr. Anvekar showed that, you know, now the end-of-arm, you can put a camera and you can see there, you can move, you can position, you can adjust, you can assemble, you can do many things. So today the end-of-arm tooling is basically a kind of a functionality which you get, which is not only the mechanical devices but also a complete control devices which has got programmability and connectivity to your main line, to your even up to the not only your MES but also to your ERP. Zimmer as such, you know, is in Germany, started very small humbly, but now we are into very complex solutions and we work across every industry. Today we are around 160 million euro business we do in end-of-arm toolings, and around 1100 people work for doing these jobs across the world. So we would like to grow with you when you have different solutions and different processes to be adopted with the smart solutions. We are there. Next slide, please. We have not only innovative components but also reliable, because reliability is very important in case of end effectors. The reliability is not only in terms of mechanical rigidity but also connectivity, the data handling speed, important way to work with combinations of different sensors, and we guarantee 30 million cycles without things. Next. And we have recently developed an STM module, which is basically digital control module. So any robot you can connect to this STM module, and that can be connected. If you see below, this is the robot panel, digital IO panel of the robot. You can connect directly there, either by IO link. You can connect the equipments, and you can connect digitally or by any bus directly to the things, and you can work as one unit for your solutions. So we say that we have almost all kind of solutions for your smart factory needs for almost across many industries. Next slide, please. Industry 4, as I told you, that coined in 2011, and that was more from the strategy from the German government to promote computerization in the manufacturing, because computers were taking decisions. AI, machine learning came in early infant stage there, and the smart factories started. What it means today in 2020, the trends are basically mainly we can say that first is a smart factory and the digital twin. Means you are not really making and doing experiments on the field. You make it, you just assemble it, and you see it, and it works directly on the field. And what you see a solution here is basically a furniture manufacturing company in France using our flexible solution for end-of-arm digital twin. Second is the flexible production. Now the people are ordering many parts on the fly. They are connected, and then you need to do it. For example, you go and you order a kitchen. You say, I want this color, that size, cupboard, that many things. This directly goes to the cloud. Cloud gives the data to the machines, and machines are prioritizing the production, and when the packs are made or machining is made based on this flexibility. So all these things are very important, and these flexible production lines are become a reality now. They were maybe 3-4 years they were the jargon lines, but now even the most of the cars you are ordering, they are on the line and like that. Next point comes is a predictive maintenance, because you know the lines are running and you cannot stop these expensive machines because for maintenance. So you must know when the time has done, when you have to replace a bearing, or how many cycles it has been done, when you have to give a compensation, when you have to change the part, whatever it is. So this is predictive maintenance cycles, which are very important, and these are now also become a part of a trend. And the smart sensors. Smart sensors are from the vision, from laser, from heat, any kind of, that's very small sensors are there. They have to be part of the system. They must be a part of your end effector, and end effector is communicating, because there are a lot of information has to communicate on a bus to the main data. So you can see a diagram here, which is explaining a little bit, but this means today, in today's language, in your industry, industry 4. So in a short, you know, you must be able to make it before, because things are made twice, one in the thinking and one in the actual. So you make it with digital twin. You can program you can do the flexible production. Your system must have predictive maintenance, and you must be able to adopt smart sensors. Next slide, please. And what is very important from us is that, you know, it's not only concept. We have to guarantee you until commissioning, and commissioning is also sometimes can be online like this. And this means the connectivity through cloud to the engineer and to the thing. So this slide here, which you see here, the middle two pictures are basically done in a design. On the left hand side, you can see it's in reality, and the right hand side you also see the two end effectors. One effector is preparing part, and second end effector is shipping the goods. So all these complete factory automation things, a function package together with robot has to be built, and this is what is very important today. And the speeds have also increased, and the flexibility is also increased. Next slide, please. How you do it? Basically you need a lot of supporting and solution oriented things, and also to be operated from various plants. Means you are not only operating from your computer now, you can do it in remote. Maybe if there is a maintenance and engineer is on the field then he attends the machine. Now the situation has gone, as we discussed just few minutes back. You know, the engineer can be far away. He doesn't have a flight because of the COVID situation. Then he can take his computer, or he can take his mobile and look, and he can do the things. So we have now developed the 5 different products we call Virtual Z, Cloud Z, Support Z, Control Z, and Visual Z. So these are very important things for us, and these are embedded in our recent end-of-arm toolings. Virtual Z means we can do this on our softwares before you are really doing the actual things. Everything is done, and all the computation and controls has been tested. Then we can do the simulation as a total package, and we can work with many simulation packages of the reputed robot manufacturers and see the feasibility of that. We also can connect together with robot our end effector and look at the remote diagnostics. You can also get the productivity dashboards and various aspects of different processes. We are not talking about only the car manufacturing process or vehicle manufacturing process. We are talking furniture. We are talking, and recently we are now developed a lot of systems for vaccine handling and pharma, medical, various things. The Control Z means you can work through MMI through cloud, and also we have developed many softwares together with reputed manufacturers like Fano, Kashkawa, Kuka, that you can also control our units through the handheld terminal. And Support Z means, of course, the online remote support. Next slide, please. So what it means, you know, go into the simple terms. Basically, this is a nice picture which shows you have a gripper where you are gripping a round part or a square part, and then the data from there is given to the box, and this box data from the gripper gives it to the data out to the robot or the control system of the robot to take decisions. this is what we call a smart gripper, and sometimes this box is not necessarily the things are also embedded in the control, but this is a total smart gripper nowadays deployed into many things. We also offer both pneumatic, hydraulic, and electric driven smart grippers, and for your applications. Next slide. So how to connect, how to work, how to do that? Earlier, traditionally, a pneumatic or electric gripper was there, and there were magnetic field sensors, and these magnetic field sensors were connected all together and connected to the IOs, and the IOs means another PLC, and this PLC was connected to the robot PLC, and there were different communications. But now with this smart end effectors, we have we can give you a box which you can see next time, whereas open close signals, all workpiece additional handling signals, and other data like force, temperature, vision can be connected. That is connected to our SCM module, that is called smart connection modules, and there is a software backup. So all these things together can come as a box to you, and then you can connect it, and then it becomes easy to work with any of the robot you choose. Most of the roboted robots has our softwares and embedded these things. This means what? They are ready for connection, and this reduces the concept to realization time. Then short changeover times means you can, when you have handling different products, you can do you can change it very quick, and we can also adapt lighter if you want to have additional things like gauging, sensing, measuring, and that too on the fly, and we guarantee rigidity and longevity. Next slide, please. Sorry. So this ready to use gate means what? Is a smart gripper which gives the servo, electric, and pneumatic. Smart data means software, and plug and work system. So if you see a thing of UR here, you get, when you are using it UR, you get all this box together, and all this box has the things, and then you can set up. Next slide. So how you do? Once you connect, you connect and configure the configuration. Then this is a simple thing which I have explained it here. Then there is then you do the second step. You define gripping. Means when you grip, you teach in, and you open, you teach in, and you say that it is internal gripping or external gripping. Then this gripping step is done. Then define the workpieces, because you are not normally doing one workpiece. You have 1, 2, 3, 4 different workpieces. So you can define different workpieces into the system. Then on a step 4, you can define the tolerances of that workpiece. You can define stroke and opening, how much you want to open, how much you want to close, and define force, and then define speed, mean at what speed you want to close and open. So all this data, once you put in, you have a recipe you see on the last picture. So workpiece recipes included, and you can program many workpiece recipes and then plug and play, and it works. So gripper configuration is done easy way, and you can start working to your robot. So in few minutes you are taking your robot into an operations. Earlier it used to take many days, but now here you can do it in few minutes. Next slide, please. So there are different data communications, and these different data communications you can put it onto the cloud. It means you are able to control this from remote places. So you have different mode, different forces. You can see that as a recipe which is on the left, and you get an output data out as a gripping cycle, system temperatures, error codes, and everything. So this data also can be to your control house, can be to your MES, and even sometimes you can do the gauging, because our accuracies are 0.1. So if you are measuring, and if you are not getting that position, you can give even a compensation to the CNC machines. So up to 0.01 mm we can control. So you don't need really additional controlling devices. So you can see that this gripper is smart, and this is one more point which you can see here. Next, please. So we have, as I explained you, we can work with different manufacturers as a comfort app. Means you buy an app from us, which is resident on a robot pendant. So this is, for example, the Denso robot, and there is a pendant here. On this pendant, there are many programs directly can be done, and you can teach in, as I told you. And once you teach in, you set up everything, and then this comfort app helps you to work there. So you don't need many things to do this programming. It means, you know, when you are buying a smart gripper, you are buying, on the left side you see the 3 different grippers, which you can select one of them which you can buy. Then you connect these grippers on an IO link level or IO level to the digital IO, connect it to our digital Z for programmation to your computer and do the setup, and then the IO level connected to the robot controller. And on a robot controller, on a USB stick, we give you this menu, which once you load this menu, it is available in your robot, and you can program it in your robot, so that you can do everything, almost every functionality of our smart gripper with the robot. And this is very important, because then it becomes an integral part of the robot. You don't have to do too many things, and it's very easy and nice. Next slide, please. So in short, it is simple installation, easy for connections. The components are registered at high-level process control system, transmit information about their capabilities, and subsequently scheduled to the product processes. High level of flexibility through options, either edit parameters or by teaching, and it is very easy. Extended diagnosis for the preventive maintenance, because now you can count how many cycles happen, you can write the different programs and parameterization, so you can really manage the recipe, and you are able to do the extended diagnostics, and you can do the preventive maintenance through this. And this can be replaced also by ongoing operations. Interchangeability, initialization operations are possible, and highest possibility machine possibility available because of this interchangeability. And this is what we call our smart end of arm toolings or smart end of arm grippers. And they are, as you see, there are more than 150, 160 different components. These components we put in together, we connect together, and we connect to your robot. And this is very easy and very supportive. And it's really smart, because as Mr. Anvega said, you can see through our end effectors using the third party. You can use your third party softwares. You can use any robot, and you can teach in for your pendant. And this is a complete system. Thank you. Thank you very much. Yeah, next slide. So thank you. If you have any queries, any questions, you can definitely call on us. Here is my number, and you can see also on our website, we have more than 50,000 different kind of gripping systems. We also have different damping systems, clamping systems, and we build systems to your solutions. Thank you very much.
Thank you, Mr. Raibagi, for an in-depth overview on the Industry 4.0 with applications through Zimmer. Our next speaker for today is Mr. Ashwin Vanekar, who's the head of Cluster South Asia Application Engineering at Festo, India. He shall guide us on the latest trends in automation and collaboration with robots. Mr. Vanekar graduated from the Saurashtra University in Gujarat in Mechanical Engineering, and he's completed his master's in Machine Tool Engineering at the Technical University of West Berlin, with specialization in automation technology. He has worked at Festo, Germany before moving to India, and has been with Festo for more than 24 years. Over to you, Mr. Vanekar. Thank you.
Yeah, thank you, Ms. Emily. A very good afternoon, ladies and gentlemen. At the outset, I would like to thank VDMA and Automatica for giving Festo an opportunity to present and to share some latest trends in the automation. Today's topic, as already has been introduced, that it's latest trends in automation and collaboration with the robots. When we talk about the latest trends, then automatically the advancements in automation also come in the forefront. I'm really happy that the perception in the industry about automation is changing, and that too at a very fast pace. The production world was never so receptive in the past as it is today. Just to give an example, if I talk about 2 decades ago, automation was perceived something as which takes away the jobs from the market, and thus maybe it was disliked and it was avoided also. Today, the economics works in the favor of automation. The investments in automations are indispensable today, are happening immense, and they are the integral part of the future planning for growth of any industry. Next, please. Next, please. Yeah, thank you. No. The second slide. Yeah. Coming to the industry segments, we cater almost to all industry segments, and we are aware that today there is no industry segment, whether it is globally or in India, which has no automation. To a certain extent, the percentage of automation, the degree of automation may vary from industry segment to industry segment, but be it automotive industry, be it food and packaging, electronics and light assembly, be it even life tech or the healthcare, also is going towards the direction of automation. Next, please. So the topics of today, I will start with the video. Can you start with the video? The video will inspire you to ask the question, are we really ready for automation, and that in what way?
Let me ask you a question. Are you ready? Ready to persist in a world that turns faster and faster? Where everything becomes less predictable? A world that demands a partner that is close to you, wherever you are. We are ready. With the expansion of manufacturing and logistic facilities around the globe, we doubled our production capability in the last 2 years. This ensures high volumes and reliable delivery performance, even in volatile markets. Are you ready for the upcoming complexity of your customer demands? With our proven experience in industrial automation, we are ready to support you from designing to operating your machine with the best technological solution and the most competitive product range ever. Are you ready for the most challenging price battles in the future? With our new core product range, we enable you to be competitive without compromising quality. We are ready. Ready for you.
Yeah, the next, please. Yeah. I think Dr. Morhard mentioned this during his welcome speech that nobody can escape today automation. Everybody needs automation because that is the only way the industry can survive today. And that's why the slide also says the same. It is a need of the economy. There is a compulsion in the market because there is a big competition, and there could be various reasons, there could be various means why the people would be going for automation. It could be the improving of the productivity or increasing the quality of the products or safety standards today, reliability of the machines, increasing the profitability. That could be one concern of the industry today. And this could be the factors which could be driving everybody for the whole industry to go for automation. Next, please. Well, we know there are many processes in the industry which are waiting for the automation or which are being automated already. The automation has ample scope in the industry. There are multiple manufacturing processes like conveying, rotating, gripping, clamping, where the automation can happen. And the industry today is geared up and today is doing a lot of automation in most of the manufacturing activities, what you can see here on the slide. The next, please. Today, we are also talking about the trends in automation and the advancements. Now, when we talk about the trends which are for the future, digitalization is the topic which will always come in the forefront. When we talk about the digitalization, it could be, as we talked in the previous slide, about increasing the productivity. It could be the value-added services, not only for Festo as a supplier, but also for the market, so that the image of the company and due to the value-added services definitely increases. When the image increases, the leadership position also strengthens in the market, and that is definitely a core reason why the future of automation is digitalization. Next, please. The previous two speakers talked about some of the smart solutions which are available. Definitely, Festo is also gearing up to the industry 4.0. That is a buzzword of today. And we hear here and there a lot of things about the industry 4.0 or IIoT. Many industries have already started doing in the smaller way. As Mr. Nath mentioned, baby steps towards industry 4.0 for industrial automation. But there are smart solutions. It could be, now there could be many reasons, as I told, somebody wants to have the energy efficient product, or somebody would like to have a smart product which can take the data which can collect the data and store on the cloud, the big data what we are talking about. So there are some of the smart solutions which in the further slides I would be talking about. Next, please. Everybody knows that compressed air is definitely costlier, not so economical to manufacture or to produce compressed air. And today the industries are talking about, definitely nobody wants to go away or escape from the compressor, because that is the one which is the driver for automation in most of the processes. And when we talk about compressor, today people are talking about how we can reduce the carbon footprint in the industries. And to reduce that, there are certain intelligent products which are available. For example, this is an energy efficient module which can do a lot of functions for saving the air or saving the energy of the compressed air. It has functions like when the machine is in standby, it knows the whole intelligence is already built inside this device or this solution. So it knows if the machine is non-functional or it is on the standby mode, it automatically switches off and thereby saves the compressed air. Secondly, another big thing what people are looking for, or the solutions that they are looking for, is if there are leakages in the machines which are non-detectable. Maybe a human eye or human ear cannot hear those type of leakages, but still machine is consuming a lot of compressed air because of the leakages. This device can also detect the leakages. That intelligence is already, this is now the smartness what we are talking about this product. That smartness is built in this device, that it can detect the leakages, and it can differentiate between a normal consumption of the machine and the leakage consumption, and thereby it automatically shuts off, and then it can be enabled when the machine has to be restarted. So this is the intelligence. Another big thing people, the industries today want is that, can I have the data of this or to be stored on the cloud? Whether I can collect the data via IoT gateway and store it on the cloud. Yes, the data logging is possible through this, and people are using this for the cloud applications. And this device is an intelligent device, the smart device for the future for saving the air consumption. Next, please. I talked about the safety. Now, there are some circuits or some components which are being used for the safety of the machines. Now, when we talk about the safety, we don't talk only about the operator safety. That is definitely extremely important, but we also talk about the machine safety, because nothing should happen to the machine also. And both are in the forefront of the automation. However, the existing traditional solutions are too cumbersome and sometimes are time consuming and sometimes not reliable. So they are a combination of different products which can be brought into a circuit and then a safety level can be achieved. But this device, the safety is already built into the device, where up to a certain we talk about, when we talk about the safety, we talk about the performance levels. So we are getting certain. So this device, when the machine is newly started, it slowly fills the air inside the machine at a very low pressure. So this is called a smart pressurizing of the machine, or the slow pressurizing of the machine, by which the operator safety is guaranteed. Secondly, when the operator tries to enter into the safety areas, so safety the safety gates, then suddenly the air gets gets dumped, or it gets exhausted at a very fast speed, and this saves the operator from getting injured. So this is the safety device of the future, and again the same device is also with IO link. We'll talk about that in the later slides, which has been inbuilt with this intelligence or a smart device, which is the future for Industry 4.0. Next, please. We are talking also about the optimization. We are talking about the digital concepts of the valve terminals, because we know that the machines are growing bigger and bigger. Then we definitely require more and more valves to operate the machine, the solenoid valves to operate the pneumatic actuators. Now there are different digitalization concepts or different topologies, I would say. The machines could be smaller, like a small room, maybe 2 meter by 3 meter or 4 meter by 4 meter. In these smaller machines, a particular topology can work, which we call is the centralized installation of all the devices, where the PLC, where the IO modules and the whole valve terminal sits at one place. Definitely there are advantages of this. It is 60% more efficient because of the functional integration into one unit. The diagnostic, the channel diagnostic becomes extremely easy because everything is mounted at one place. But there are other concepts also which are there. We'll look into that. Next, please. Yeah. We talked about the centralized concept. Now we talk about the decentralized installations. Now, why they are necessary? Machines, as I said, are growing bigger and bigger. They are also becoming longer and longer. Now, for example, machines in glass industry or textile industry, they are sometimes up to 100 meter, 200 meter long. Now, if we go for centralized installation, it may not be fruitful, it may not be serving the purpose. First of all, the air consumption will be extremely high. Now, because of the decentralized concepts, there are different modules, or all the systems are sitting at localized stations where the functions are already happening. And because of that, the cycle times, first of all, the biggest advantage of the decentralized solution or the installation is the cycle times are extremely fast, or they are quite fast. The air consumption, we talked about the previous slides where we talked about the reduction of the carbon footprint. Now the air consumption becomes extremely low because where the actuators are located, the valve terminals and the IO modules are sitting there, and just through one bus cable, the whole communication can happen, where the PLC is sitting somewhere in a control cabinet, which is the master PLC sitting somewhere as a standalone device somewhere in the room. Yeah. Next, please. As we are already on the topic of on the decentralized installations, the latest trend in automation is that how much a decentralized solution, a standard or a traditional one, can handle. When we have devices which can go almost up to 500, will that be able to handle? When we have the length between each device is 50 meter or even more, will that be able to handle? So exactly, this is the solution which we call the digitalized, the decentralized remote IO system, which is a part of a controller which can almost communicate. And first of all, communication today is a big problem. Some of the machines have Ethernet IP, some have Ethercat, some are on the CC link, and some are on Profibus, Profinet. So many communication concepts are there in the industry. Now this is the one which can communicate with almost each and every host which is available in the market. Another big challenge is what type of topologies, because some people say that I have a line topology or a tree topology or a star topology. Now this is exactly the solution for this type of variants in the topology. Absolutely no hassles. This is also equipped with the IO link, which is we know is a step towards Industry 4.0. And people also want that the processes should become extremely fast. Now, just having a remote IO is of no use, whether it can handle the fast processes. And this can actually handle all the processes at the real time with extremely short burst cycles up to 250 microseconds. The speed can go up to almost 200 megabytes per second. And so fast is the communication through this device. So this is an alternative, I would say, an optimization in the decentralized installation, which is the latest trend today. Next, please. We talked about some of the smart devices. As you can see the architecture here, that right from the field devices, how the communication is happening. And then we have a smart controller, which can be purely used as just as an IO system, or like a control, like a PLC system with certain inputs and outputs. And then through the IO link, because it's also equipped with, because most the Industry 4.0 talks about the IO link, and IO link is a step towards Industry 4.0. And that's why the communication can happen through this, through the IoT gateway. And then when we talk about the IoT gateway, definitely the industry platform today, where the communication language or a software interface, a common software interface, which is being used for the Industry 4.0, we all know it is the OPC UA. So the devices are also equipped with the OPC UA, and through the IoT gateway, the data can be stored on the cloud and then can be brought out or brought down for any type of analysis and for future references. Next, please. Coming to the topic which takes us toward the Industry 4.0, the IO link. Now, IO link actually is being misunderstood in the industry, is that it is something like a bus protocol or some type of industrial bus. No, it is just a point-to-point two-way communication between the devices. Till now, it was happening that, let's say I just give an example of a pressure sensor. A pressure sensor was being parameterized. It was being taught in for some values like threshold value, normally open, normally close, at what point it should switch off, and all these things, the parameters were being taught into a pressure sensor. Now, pressure sensor, when the signal was there, it was just communicating with the PLC. It was giving an output signal to the PLC. PLC knows only that. Now, when PLC wants to communicate with the pressure sensor, it was not happening. When some data or some parameters needs to be changed on the pressure sensor, physically the operator had to go to the pressure sensor, touch it, and then change the values. With IO link being a point-to-point and a bidirectional communication, this is not necessary. Directly, when all the parameters are being loaded on the pressure sensor, PLC, the controller, exactly knows what data is there on the pressure sensor. And then whatever changes need to be done can be done directly sitting in the office, and then nobody should go to the field to touch the devices and change the parameters. Another big advantage of the IO link technology is that when a faulty device needs to be changed and replaced by a new one, the moment the new one is there, the PLC knows that there is a new device, and then it downloads all the parameters and all the data which were on the previous sensor, and the work is done. No need of reparameterization, no need of reteaching. So that is the beauty of the IO link. Next, please. Yeah. When we are already on the IO link topic, maybe in the industry, the image of Festo is more towards that Festo is into the compressed air solutions, that is pneumatics. But for last 2 decades, we have been changing our image, and we are going also more and more towards electrical automation. And when we talk about the electrical automation, definitely servo motor and ball screw drives and controllers and whatnot, everything comes in the picture. And then the programming of that with different motion profiles and all that comes into the picture, which is definitely good and is a need of automation. But there are certain applications or certain production halls which say that we don't want a complicated device, we don't want any programming, we don't want any hassles to do with the servo motor. We want the advantages of pneumatics, that is the simplicity, with the advantages of the electrical automation. Now, how that can come? Now, this is called a simplified motion series. Many people also would like to, or in the industry, they want to shift It could be the reason of the carbon footprint also, will shift from pneumatics to the electrical automation due to digitalization. Now, carbon footprint is one of the reasons, but definitely digitalization also could be the reason where the industry wants, in some of the applications, some of the functions, would like to shift from pneumatics to electrical automation. Carbon footprint is another reason. There are reasons which are very typical reasons where people say we don't have air at all, we don't have a compressor, we don't have compressed air at all in our production hall. Let's say it could be area like logistic. Now somewhere above something, a carton or a shipper or has to be pushed out, and then nobody can bring compressed air up to that point. And then what can we do? But a simple solution is needed. So this solution has the motor and the controller, everything built in. Absolutely no skills are required by any programmer to program it. It is just the switching on of the the digital buttons, the push buttons, where the stroke length, where the speed, where the force is, can be varied on this. So this is a hassle-free, easy to operate electrical solutions with a motor directly sitting on it with the controller. No control cabinet required, nothing required. There are also applications in the clean room areas where the compressed air or carbon footprint is not allowed to increase there. There are less noise pollution areas in such areas. In the hospitals, I talked about on the first slide about the med lab, about the life tech technology application, where noise pollution almost is negligible or is not allowed. There, this type of solutions can be used. Next, please. Now, this topic is something, it's a revolution in the field of pneumatics. Of course, in the digital age, this device is for the industry 4.0, and this is called the motion terminal. We talk about so many applications which are done with pneumatics. It could be a high-speed motion, it could be a slow-speed motion, it could be a pressure control, it could be a force control required due to because of pneumatics, and all these applications require so many different devices, so many different type of programmings, and all these hassles are being now done by this unit, which runs directly on, which is controlled by the motion apps. Now, the way we have apps on our mobile phone, and it becomes easy to operate an app, the same way, just through the app on the PLC or on the laptop or on the mobile, this device can run any application with pneumatics in any function on the machine. We will just have a look at one of the apps. Can you please start the animation?
You can just unmute and talk to yourself.
Sorry, I was on mute. You can see the water in the glass which is vibrating. Now, another solution could be using hydraulic shock absorbers on the drive, but you can still see that the application is not satisfactorily working as per the demand of the customer, and he still needs, because the precision is required in the end position and jerk-free stopping is required. So this is now all taken over by the app, which is called a soft stop app. And then you can see absolutely jerk-free motions are happening without compromising on the cycle time. That is extremely important. And similarly, there are so many other apps for force control, for motion control, for different stoppages on the way. So all these things are done with different apps. Yeah. Next, please. When we talk about the trends in the technology, till now we talked, or even the previous speakers, they talked about the trends which are happening in the manufacturing production hall. Now there are different applications like logistic. Now, logistic is such an area with extremely high potential of automation, which is now slowly coming up to that level that they are now demanding a lot of automation in the logistic. One of the examples you can see on the left side, it's a typical e-commerce logistic go down or a hall, where components are or the boxes are being stored, and they have to be brought, or it's called actually an ASRS, it is automated storage and retrieval system. Even there are applications for interlogistics. Now we are talking of the ASRS, where as per the command or as per the destination, the goods have to be brought on the pallet and then they have to be shipped to a different destination. So these are the Z lifters or vertical lifters which are surrounding this whole production or this go down or this the storage hall, and they are doing this job as a Z lifter or a vertical lifter and bringing those boxes up to the storage station or away from the storage station for the dispatches. Similarly, there are applications which I talked about when I was talking about the electrical drive, the hassle-free drive, where just pushing applications in intralogistic are also today happening through, and then they are also demanding a lot of automation. Simple jobs like diverting a particular box to a particular destination or pushing a box to a certain destination. All these are the part of the automation which are there in the industry and which are there in the logistic. Next, please. Now we'll come to the collaboration of the how Festo collaborates with the robot. Now here you can see a typical body shop where the welding robots are doing that. They are in action. Now when we talk about the car body building, we require extreme high precision. The cycle times are extremely challenging, and all they need what is and we know the weld shop, they are the spot welding applications in the car industry for this type of components in the body shop. And Festo provides solution with for the welding gun, for the spot welding gun. Either it could be a servo pneumatic solution, where we in the previous slide we saw how the motion terminal can do a soft stop or a multiple position stopping is possible without any jerks or without any impacts. And typical servo pneumatic solution would demand, when the spot welding is happening, that when it goes for the spot welding in the end position, there should not be any impact on the component. Actually, that can be done through the servo pneumatic. If further flexibility is demanded in terms of different positions, different velocities, different motion profiles, then servo pneumatics, then we have a solution called electrical automation, the electrical drives, which you can see on the top right photo, which are doing the job. They are moving the welding guns to the position with utmost control over the force and the position, with extremely high accuracy, which can almost go up to 10 micron position accuracy. Next, please. When we talk about weld shop, there are different applications also where the components need to be conveyed from a place where they are. For example, here we are talking about a car door which needs to be picked from one position to the other position for further welding, and the grippers which are being specially used. So here we are also talking about the end of the arm tooling, how we equip the robots with this type of special technology. So you can see a servo-driven technology being the robots are equipped with that technology along with the linear drives, and they can go to different positions, and they are equipped. The positioning axes are being equipped with a pin clamp cylinder. So the pin clamp cylinder, they engage, they locate the holes, and they are engaged into the holes of the door, or it could be a hood, it could be bonnet, it could be anything, and then they clamp those components, and then they are being shifted from one place to the another place. So it's a typical handling of the car door, or it could be any component in the automotive industry for building applications. Next, please. There are applications when the components grow bigger and bigger, that means bulkier, and as the component size increases, sometimes the weight also increases. And there are limitations for the grippers. We saw that the end of the tooling the robots can be equipped with the grippers which are available in the market. And Festo also supplies the grippers for this application. When the components grow in size, when they grow in weight, then definitely standard grippers may not be the solution for this type of applications where the robots can be equipped with them. But robots definitely can be equipped with a very special type of customized gripping solutions, where Festo's electrical drive comes in the picture. You can see some of the electrical axes of Festo, a very different type of mounting, a very special type of mounting arrangement has to be done on the robot, where the robot can pick and place this component, grip these components, and do the handling of these components. Next, please. What we saw were all the mechanical grippers or the customized grippers with the electrical automation. But then what about certain components which are flat? Now these components, they are typically in the final assembly. So the robots are definitely operational in the final assembly in automotive industry. And when it comes to the handling of the windscreen and then handling of the parts like seats, bucket seats, which are to be located and placed inside the cars, then definitely different solutions come in the picture. But here we are talking about now the vacuum technology, which comes in the picture when it comes to handling of the delicate glass. So when it comes to the windscreen, definitely a normal gripper cannot work. It cannot be implemented here. So we are talking of the complete vacuum technology which is being used in this. And when we talk about the vacuum technology, definitely for the safety of the operator and for the safety of the component, there are certain safety features which are being loaded on the vacuum generators. We are loaded with the vacuum sensors, and they are loaded with certain special technology where even if the vacuum fails, the component should not fall down. So all this technology comes in the picture. So the safety of the component is being guaranteed here, and that is the trend and that is the demand of the market. Next, please. In the previous speakers also talked about some applications which are happening in collaboration with the robots, and definitely this is one of the areas where we are handshaking. We are doing a handshake with the robot where we call it a 7th and 8th axis, because we know that robots can have 6 axes. But then what about the applications where robot, because we know that robot can only cover an envelope surrounding it, but what about the applications where it needs a longer travel, a 4 meter, 5 meter, 8 meter, 10 meter a long travel? And definitely the linear axis, which we call the Cartesian robots of Festo, they come in the picture here and they can be implemented. You can see on the left side applications happening in the palletizing it's a palletizer where the carton boxes are being picked from a conveyor and they are being stacked and palletized on another conveyor, where a robot is mounted on our 7th axis and 8th axis. So 2 axes come here in the picture when it comes to different type of motions, a different type of travels, and how much the area the robot needs to cover. On the right side, it's a typical CNC machine tending application where in line there are 4, 5, 6 CNC machines, and the robot requires a travel from the first CNC to the last CNC machine for loading and unloading of the component, the finished goods and raw material to be loaded and conveyed from one CNC to another CNC. So these are the typical applications, how we collaborate with our linear axis with the industrial robots for fulfilling all the complete requirement. Next, please. So that's all from my side. I thank you very much for patiently listening to me, and hopefully I could share some of the latest trends and advancements in automation and how we collaborate with the robots. Thank you very much.
Thank you, Mr. Vanikar. It was indeed quite interesting to see the entire spread of how it could be supported through automation and what is coming up in trends. I think today's discussion would be incomplete without our robot manufacturer on board, which is Kuka. We have with us Abhishek Sharma, the manager of sales at Kuka India, and he'll be speaking on the latest technologies on the robot applications in the automotive and tier 1 and FMCG industry. Abhishek is responsible for handling automotive OEMs and tier 1 business, and he's having more than 10 years of experience in the field of sales, business development, and project management. He's done his bachelor's in engineering in mechanical stream. Over to you, Abhishek, with no further delay.
Thanks, Jamli. I think we'll quickly switch to the presentation because we are already running a bit late. Not a bit, but yes, a bit late, but I'll try to cover the presentation as fast as possible. So here's the presentation from Kuka side, so which is divided into 2 parts, about a small company introduction and the topic for the presentation today. So next slide, please. So just to give you a brief introduction about Kuka, so under Kuka roof, we have 3 different divisions. One is Kuka Robotics, which deals into robots and its related accessories. So then comes the Kuka Systems part, which are actually working and providing the complete solutions, mainly into the body shop applications. Industries applications, Kuka Industries is another division under Kuka Systems, which are into specialized technologies and in heavy fabrication. The third division which we have is the Swisslog, which are the experts in the warehouse automation. So all these three divisions are actually comes under Kuka, and we are a one-stop shop solutions for you, starting from the robotic automation to the warehouse automation. Next slide, please. So Kuka as a robot supplier and as a cell manufacturers are working in different industries, which covers almost all the industries globally. First one is the automotive industry, and the other industries where we work definitely are the aerospace, logistics, entertainment, machine tool, and all these are other general industries where Kuka is having a strong presence globally. Next slide, please. So with a legacy, we would say of more than 120 years. So we were the first one to develop the robot, electromagnetic robot in 1973. Since then, we are actually working hard to develop new technologies into robots, whether it is a long arm robot we have, whether it is a heavy payload robot we have, or the new technologies coming in. For example, the entertainment robot, which is one of its kind, and collaborative robots. We have a 1,000 kg payload robot. We have cooperative robots. So we are the first one to develop all these technologies, and we are really proud of it. Next slide, please. So with the help of VDMA and in association with Automatica, we are here to present on the technologies into robotic applications in automotive and tier 1, and definitely the FMCG industries. Actually, automotive and FMCG industries are a bit different in the operations, but yes, we will try to see, because the robots are used in both the applications and both the industries. So we'll first present the robotic applications and the latest technologies into the automotive industry. Next slide, please. So one of the important or the challenges what future productions are facing right now is definitely the duration of product cycles. The duration of product cycle means earlier, for example, when a car, it used to run for 6-7 years, or a car model, it used to run for 6-7 years. Now it is getting reduced to 2 or 3 years. So the models are changing very fast, and which also the quantities which are being produced for a particular model are also getting reduced because you have multiple varieties. So varieties are increasing, quantities are getting less. We have shorter product cycles. So what we need is a complex production, which is now actually coming into picture. So the complexity is increasing. So what we have to do is we have to increase the efficiency of the production. So, and with over that, product customization is also one part which is now playing a big role. So, and moreover, we cannot deny the market demand, because market demands we don't know. Sometimes market demands, for example, for a country like India, we have market demands very much fluctuating. So definitely market demand is one. And when we talk about the area requirement on a shop floor or for production area, it's going to be less. So we already have the processes, we have the procedures, as mentioned by the earlier speakers. Also, digitization is definitely one of the key for the future. So we have flexibility into the production. So when we talk about procedures and the processes, and we combine it with the digitization, we are coming up with the new technologies into the production areas. Next slide, please. So when we talk about the traditional way of producing, for example, a car. So what we have is we have a production specific tools and a production specific equipment. So we have a standard line with a conveyor technology, which is a monolithic way of producing the cars, where we are producing 1 models, 2 models, or 3 models. But nowadays, when things are actually getting changed, we have to go for multiple model line. We have to invest for different models coming up every year. So we need to have flexibility in production. So with all these limitations, what are being faced with the monolithic production, we are there is a new concept which is coming up, which we call it as a matrix production. So next slide, please. So when we talk about the matrix production, what the first thing which is being done while designing a matrix production is the production and the logistics are being separated. What does it mean is, so the production is actually a production neutral cell. So that means you are providing a specific type of tooling, specific type of fixtures to the cell, and you make it product specific. So logistics is a different part, and then you are separating it from the production to make it a flexible line. And definitely you are replacing the traditional conveyor systems or the traditional skid systems for transferring the fixtures or transferring the cap or transferring the parts by replacing it with AGVs. So AGVs is definitely one of the important, I would say, one of the important product which is playing a key role in achieving the flexibility. So next slide, please. So this is typically how a matrix body shop will look like. This is an overall view. So you can see here below is the production area, and you're separating it from the warehouse. There is a strong software digitization has been done. A strong software platform is developed to interlink all the cells with the warehouse, with the AGVs, and with the tool store. So it depends on depends on the cycle time what you want, depends on how many products you want. So you can define the cycle, you can program it in the software how many cells you want to operate, how many flexible to make it flexible, how many cells you want to operate at one time, and when you want to change a product, so how flexible you can change the product. So this is typically an example of a matrix body shop where the cells are not directly linked to each other. Those are connected through AGVs. So there is not a physical linkage between all the cells. So with the warehouse automations, the specific model is being fed by the AGV to a particular cell, and then it is moved to different cells depending on the application. So here are the two video links actually, which I think the presentation which will be shared with you all, so you can have a look at it, which are more descriptive, where you can have more idea about the matrix production. Next slide, please. So this is just a typical view how a matrix production cell looks like. So usually it is a combination of 4 robots, AGVs. We have a tool stand. We don't have a fixture in this case. We have what we call as a jigless production, where the robots and the robots are actually handling the jigs, and the other two robots are actually doing spot welding or other applications on the same. So with this, we get a flexibility, and we are replacing the conventional jig system by making a jigless manufacturing. AGVs are definitely going to play a major role in it, because AGVs are helpful in transferring the components in and out of the cell. Next slide, please. So other than AGVs, other AGVs are definitely which are being used for the new production areas are actually high-end AGVs. These AGVs are not magnetic strip driven. These are not inductive or optical driven. These are actually the laser-based AGVs which work on laser scanners. So it can work in any direction. It can move in any direction on a shop floor, rather than moving in linear or a Cartesian system. It can move in any direction on a shop floor. So that gives more flexibility in the movements on the shop floor. AGVs, as the AGVs are playing a bigger role, the transport systems are also coming into picture. The transport systems which are being developed are actually flexible enough. These are actually the next step of the skid system which is being used conventionally in the automotive production lines. So we have pallet-based systems which are being developed, where you can have different pallets. You can those are interchangeable pallets which you can actually use it in a production line to have a flexibility in production. Third thing, on the top right side, you can see we have when we talk about a framing station. Framing station is actually an area where the geometry or a car body is formed. So when we talk about a framing station, so coming to that, we need to develop a system which is actually accommodate 4, 5, or 6 different models. So we have a multi-model framing stations, which is definitely being used in automotive areas for flexible production. And last but not the least, the jigless manufacturing, what we discussed in the above. So in that part, we are actually replacing the conventional jig systems, which are actually a bigger limitation in flexible production. So we are replacing it with jigless manufacturing, where the jigs are actually mounted on the robot, and you have multiple jigs, and you can do the complete programming and production more flexibly. Coming to the next slide, please. Coming to the next slide, yes, as everybody mentioned about the collaborative robots. So definitely collaborative robots are the one which are being used into production nowadays. And the different applications which are being realized into the automotive industry and in the tier 1 industries are specifically for the bolting applications, handling applications. Gluing is the one which is being done extensively using collaborative robots, riveting, plug setting. Qualifying is a typical application. Actually, in qualifying, the areas where the collaborative robots are being used is into the assembly lines to measure the gaps and flush in the car body. So that was actually earlier a manual job, which is now being replaced by collaborative robots in an assembly line. And in the next slide, we'll just show you there are just to explain you how human robot collaboration actually works, or what are different type of human collaboration which is there. So in the presentation, if you see here on the left hand side, we have a full automation where there is a defined area for the robot and there is a defined area for the human. So there is a physical barrier which actually protects the robot and the human to share a common area. So in this scenario, the robot works in its full speed and the operator can work safely outside the zone. But when we talk about human robot collaboration, so there are different scenarios which are actually existing. So that means there is a coexistence. Coexistence means there is a robot and a human, but it's not necessary that you need to have a common working area. But yes, it is a type of human robot collaboration with the involvement of sensors we have, with the involvement of sensors and safety curtains which we have, which are being developed now, so we can have a coexistence human robot collaboration. Cooperation means yes, there is a common area where the robot is also working and the human is also working. And when we talk about a collaborative or a completely collaborative robot, that means the robot and the humans are working on the same component, or they are working jointly to manufacture or to produce a part. So when we talk about a full automation and a human robot collaboration, there is a difference in the robot speed. So when we talk about a full automation, the robot runs at its full speed. But when it's a coexistence, or when it's a collaborative type of workspace, so in that case, the robot has to run at slow speed so as to avoid any fatal or a human or some fatal error. Next slide, please. Next slide, please. Yeah, so we talked about the issue or the problems or what are the challenges which are being faced into the production scenarios. Now we are talking about the new joining technologies. As we all are now moving towards EV segment, and everybody is talking about lightweight cars, and with the new materials coming in, and specifically the use of aluminum in the production scenarios. So new things and the new joining processes are being used in joining. So how from a robot side you can join aluminium using the same conventional spot welding application? So we call it the application which is available is a RoboSpin, which actually means is whenever robot is doing a spot welding, it is just giving a slight motion or rotation to the welding tips, or the complete robot is moving for some degrees. So what happens with this is, you can see at the bottom there are the heat input areas. Because the use of aluminium, you have oxide layer on it, and when you are actually because of oxide layer, you have to pass high current. By giving a small rotation, actually you are removing, and the force which is being generated with the spot welding, you are actually removing the oxide layer, because of which you are actually you need to pass actually a less current inside for spot welding, and that gives a proper spot welding in aluminium components. Other than that, aluminium being a softer material, what happens is, if you are directly spotting it using conventional method, because being it softer, it sticks to the tip. So by giving a small rotation to that tip, we are actually ensuring that the material is not sticking to the tip. This increases the life of the tip. So this is how by incorporating a small motion technology in for spot welding application, we are actually doing aluminium spot welding with a conventional spot welding gun. Next slide, please. So this is typically how a robot will look like. When you are doing a spot, so robot is giving a motion, and it depends on the area which is available for you to do the motion. So the angle of the robot motion is configurable. So you can configure it from 0 degrees to 10 degrees or 15 degrees, depending on the area you have or the available space you have inside a cell. Next slide, please. When we talk about EVs or lighter material being used, so thermoplastics are definitely the another type of material which are being used extensively into the automotive industries now. these cannot be joined using our standard spot welding or gluing technologies. So there are some different applications which we call it as inductive gluing of the composites, by which we can actually, with the use of a magnetic field, we are generating a heat, and by applying a small pressure, we are actually joining the two different material. And when this kind of inductive gluing tools are being customized as per the robot, so we can actually join different materials in different degrees of freedom and different profile also. So with the addition of robots inside that, we are actually making use of robots into joining different materials also. Next slide, please. So typically, what we discussed till now is about the automotive and tier 1 industry, where we are facing issues because of the complexity of the production and what are the new technologies being developed for joining the new materials. The similar issues which are being faced in the consumer good industry, specifically into the food industry, is because now people need more shelf life of the food. So for that, you need to avoid human intervention in manufacturing of the goods or the material which we are producing. So typically, how a consumer good industry will look like: there is a raw material which is coming in, which is being processed, which is packed, stored, and then they're distributed to the distributors, and then it went to the shops. So it is a long cycle, and which consumes a lot of time. So the product has to be, specifically when we talk about the bakery products, or when we talk about the sweet industry, so these products are having very less shelf life. So to overcome that and to avoid human interference in that, there are the robots. The robots are being used in the pre-processing and in the post-packaging industry also. So when we talk about the process industries, where typically we are talking about the bakeries, where we are typically talking about a meat industry, or with the sweet industry, specifically when we talk about in India. So the robots are actually being used in primary packaging or primary working or direct contact, where the robots are directly coming in contact with the food, with the processing, during the processing stage. After that, the robots are actually being used to pick it up and place it in a carton. They want to place it in a box, and those cartons are then being packed. After packing these robots, the robots are being used for palletizing applications, for storing it in the warehouse. And in the warehouse, when these products have to be dispatched, the robots are being used for depalletizing and other applications, so that it can be dispatched to the distributors. Next slide, please. So we are talking about different applications. So on the left hand side is the typical pick and place application, where the robots are picking the material in the initial stage, and they are placing it into the box, and the box are being then stacked into cartons, and these are being palletized in the warehouse. So there are other options which are incorporated in these kind of application, which involve vision-based systems, where the robots are actually picking the food coming in any orientation and then placing it in the box. Conveyor tech, yes, because on these production lines, the conveyor is continuously moving, so the robot has to synchronize themselves with the moving conveyor, and with the help of vision, they are actually doing this, where they're fulfilling the requirement. Then we have safe operation, where the robot and the humans are working together. So it is an additional safety which can be incorporated making the use of sensors and other technologies, so that human and robot can also work together. Next slide, please. So when we typically talk about the primary processes in FMCG industries, where the robot has to be in contact with the food directly, so there are special kind of robots which are being developed for these applications, which are usually called hygienic machines. So while designing these robots, or while manufacturing these robots, it has to be taken, means the things which are being taken care is that these are easy to clean and design. They are actually corrosion resistant, and they are actually food compatible lubricants which are being used in it. And wherever possible, all the components in the robots are used as stainless steel. So with the use of hygienic machines, we are actually, or the industry in FMCG are being actually using robots in the primary stage of manufacturing itself. So this is typically how robots are being used in automotive and FMCG industries, and with the development or with the complexity in the productions coming in, definitely robots are the one which are going to play a major role in achieving the goals of all the industrial types, all the industries type. Next slide, please. So these are the presence of Kuka India. We have our head office in Gurgaon. Here are the contact details mentioned, and we have our branch offices in Pune. So these are the two offices which we have. And thank you VDMA and Automatica for giving us platform to present our about company's presentation. And now let's move to the question and answer round.
Right. Thank you, Abhishek, and I would like to thank all our speakers, Vikas, Sunil, Ashwin, and Abhishek, for the, I think, excellent presentations we had. In fact, I think it was really an amazing participation just for our speakers as well as our viewers. We had more than 350 people joining this web seminar today. And I could, from my experience, at least identify 14 industries. So people from 14 various industries joined the web seminar. So I think this talks also of the quality of our speakers and the companies they are representing. So thank you very much. Actually, we are quite overshot our time. So there are a lot of questions, but I will just quickly take one question if you don't mind. We will quickly go through one question for each of the speakers, and the remaining questions then we will send to the speakers. So let me start with you, Vikas. The first question, or one question for you, is what is the maximum field of view possible for detecting objects?
Well, the field of view depends on a lot of factors. First of all, it's the other way around. Like the field of view is decided based upon the component. So, and also the accuracy that we are looking for. So whatever is the component plus the fixturing tolerances we have to accommodate, and then we decide upon the field of view. And it is also a function of how high you are mounting the camera and which lens you are using. So based upon the object and the fixturing tolerances, we have to back calculate. We have to decide what is the field of view and then back calculate what would be the focal length of the lens used in that solution for the camera.
Thank you, Vikas. Sunil, coming to you now. How is force controlled in gripper for different materials?
Yeah, actually, you can have a force torque sensor and get the feedback from the force torque sensor for the different materials. And also there could be, means if you could program the compressibility and if you know certain factors, you can also do the programming that way for the, especially for the plastics and composites. There are different areas to handle this thing. But if you're what prominently you're looking at, displacement or force, or how is the force measurement you're looking at, that that decides which kind of sensory elements you should use and control. That's my answer.
Okay, thank you, Sunil. Ashwin, coming to you now. Which module of safety valve of Festo is achieving Cat 3?
Yeah, good question. We have even different safety categories also, valves available for different safety categories. We have up to safety category 4 also. So safety category 3 is also there. But would the delegate like to know the specification of the name of that? Then it is called MS6, yeah, MS6 E2M, MS6 EV it's called. MS6, sorry, MS6 SV it's called. MS6 SV. Okay. Yeah. And then there are different category levels available. Category 3, category 4 also is available.
Okay. Abhishek, coming to you, is robotics cost-effective installation for MSMEs?
Yes, it is there because if you see the current trend, which is now being shifted from automotive to the general industry, so the robots are being used more into the general industry side rather than into automotive, because from the automotive side, things are already in production, they already have full automation. But the second industries which are being taken or which are being targeted globally is the general industry and MSME markets. Yes.
Okay, thank you. So friends, with that, I would like to conclude the session. I would like to thank our chief guest, Dr. Mohad, also our esteemed speakers who have contributed immensely with their depth of knowledge on the subject. And I would also like to, in fact, thank our viewers. I think it is an amazing participation we got. And even now, whereas it's almost 2 hours running, we have around 250 participants who are still logged in. So I think thank you very much on behalf of VDMA and all our speakers for the active participation from the industry. And also we look forward to welcoming all our participants also at the Robotomation Symposium, which my colleague James Lee mentioned on 19 February 2021 in Gurgaon. I would also like to thank my colleagues James Lee and Parth and Manohar for, I think, very effectively coordinating and pulling through this web seminar. Friends, I would like to conclude with an address from Bill Gates. He said the first rule of technology used in a business is that automation applied to an efficient operation will actually magnify the efficiency. So on behalf of VDMA and all our partners, wishing all the members and friends from the industry, Merry Christmas, wishing you all a healthy, safe and resilient year 2021. I'm sure the year 2021 will bring us much more cheer, and we look forward to the reboot of the Indian economy also. Wishing you all a good festive season, stay well, stay safe and stay connected with VDMA, and thank you for joining. Thank you very much. Thank you.
Yeah. Thank you, sir.
Yeah, thank you. Bye. Goodbye.
Yeah.
And stay
Bye.
well, all of you. Thank you.
Bye.
Thank you. Bye-bye.
Bye-bye.
Bye.